In order to come up with our design, we wanted to think of something that would be strong, reliable, safe, and simple. Traditional drone designs have a main cockpit with 4 arms branching out from it with the propellers attached to it. While strong enough for unmanned drones, these arms need to be strong and thick in order to support the weight of not only a person, but a cockpit designed to carry them as well. This is when we decided to have a square frame and a base plate that would support the cockpit as well as provide mounting for the motors. This would all rest on top of a circular frame in order to elevate the propellers from the ground. In order to transfer our design to a 3D design, we first had to figure out the dimensions of the frame tubing. For the circular frame, we decided to make each circle 4 feet in diameter, with the thickness of each tubing to be 2 inches wide and 5 inches tall. For the square tubing, we had the total length to be the total width of the circular frame, which is 8 feet. The distance between notches was the center-to-center distance of the propellers, 4 feet, with 2 motor radii added such that the square frame acts as a boundary for the motors. For the square frame, we decided to use 2-inch by 4-inch tubing. The result of our planning came out to this design. Firstly, we decided to make the cockpit windshield out of polycarbonate in order to have a transparent windshield that is also shatterproof. For the frame, we decided to make it out of aluminum 7075 tubing to reduce weight while still providing rigidity and strength. The entirety of this frame was designed to make manufacturing as simple as possible. The square frame features notches in the tubing that creates an interlocking frame to minimize the number of pieces required, in addition to making assembly faster. The square frame is welded together and then welded onto the base plate. The circular frame is also assembled through welding and then is welded to the bottom of the base plate. This reduces the total amount of fasteners and thus greatly decreases the number of parts needed in total for the drone. The circular frame below the base plate serves 2 important purposes. Firstly, it elevates the propellers off the ground. Secondly, it protects the propellers and other things from collisions. This is incredibly safe as it prevents anyone from being injured by the propellers. In this motion study, all 4 propellers rotate synchronously in order to generate the necessary lift. For most of the tolerances on the drone, we decided to go with a standard tolerance of plus or minus 5 thousandths, which is commonly used for industry. For the fit between the motor output shaft and the hub of the propeller, we decided to go with an interference fit of LN1. We did this to ensure the propeller was properly attached to the motor's output shaft. In addition to this, we made a keyway on the output shaft that would fit the hub specifically in order to ensure proper rotation. We also used an RC1 clearance fit on the bolt and bolt holes for securing the cockpit and baseplate, and framing the baseplate together to ensure additional proper attachment. All bolts and bolt holes share this type of fit on the drone.